Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we'll be looking at some of the hardest Edexcel questions on probability. So straight in at question 22 for 6 marks, we have here that there are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. So when I first read that, in my head, I'm already kind of translating it into algebra. When you've got 2 different things, so in this case, green pens and then blue pens, sometimes it calls for having 2 different letters, G and B for example, but sometimes you can only have 1 letter because there might only be one way to create an equation. So in this case, what I'd like to do, especially when there's a comparison between the quantity of one thing to another thing, is I label the smaller quantity X. In this case, the green pens would be the smaller quantity, so that would be X. And then therefore, the blue pens is 3 more, so that is X plus 3. So they're both in terms of the same letter, just because I feel like more likely than not, we're only going to have 1 equation from the information given, and therefore I only want 1 letter. If they do give you 2 equations, or information to create 2 equations, or they hint to you that you should use 2 different letters, then you can also do that. But otherwise, try to stick to maybe just 1 letter. So we've got green as X, and then blue is X plus 3. Then they've told us that there are more than 12 pens in the box, which I feel like we'll just have to leave there for a minute and come back to it at the end. So Simon is going to take, at random, 2 pens from the box. When they say something like this, in this case the context is pens, could be counters, could be anything, we're going to take 2 of something, it's hinting to me that I could draw either a probability tree or I could at least use the logic of probability trees to figure this out. Because there are what I call 2 events. The first event, which is the first branch, would be picking out the first pen. And then the second event, or the second branches, would be picking out the second pen. So that would create a probability tree style. They've then told us that the probability that Simon will take 2 pens of the same colour is 27 over 55. So that's where our equation comes from, is 27 over 55 equals 27 over 55. And the actual question is to work out the number of green pens, which luckily we've worked out green to be X, so we're effectively wanting to create an equation with the context of probability, and then once we've got the equation, we can just solve it. So you don't necessarily have to draw a probability tree. If you can visualize it in your head, that's fine, but I just like to have it written down. So we want to figure out what this sentence here means. Probability that Simon will take 2 pens of the same colour. So that is here our first pen, and our second pen would have to be the same colour. So there's only 2 options there, isn't it? We could either get green, and let's call this one green as well, or we could get blue and blue. Obviously then you've got blue and green here. But the options that actually satisfy the sentence that they've given us, and therefore our equation, would be for him to pick either 2 greens or 2 blues. Those are the 2 options, and those are the branches that make up the 27 over 55. So if you remember how probability trees work, we always multiply between the branches, because it's like green and green, blue and blue. The and rule is multiply. And then if you've got multiple options here, these are either or options. So the or rule is plus. And then that would equal 27 over 55. So let's actually try and write down some probabilities. We don't know any individual probabilities of green or blue, so we're going to use our X. So the probability of picking green first is X out of all of the pens. So our total pens, if we were to write it here, is obviously green plus blue, so X plus 3. So that would be 2X plus 3, wouldn't it? That's how many pens are in the box as a whole. Now, when he picks another pen, because he said, oh, he's going to take 2 pens, it doesn't suggest that he's going to replace them. It just seems as though he's going to take one and then immediately take another. So when we go back for our second pen, there's going to be 1 fewer green pen and 1 fewer pen overall. So instead of plus 3, we can make that plus 2. Same for the bottom one. So for blue, we know it's X plus 3 out of 2X plus 3 because we still haven't taken one yet, that's the first one. But then blue again, we've already taken 1 blue, so that would have to be X plus 2 left of the blue ones. And out of all of them, obviously, 2X plus 2 overall. Now, this is going to be a massive equation to write out. as I said, you would multiply between the branches. So to get both green pens, it would be x over 2x plus 3 multiplied by x minus 1 over 2x plus 2. That's the probability of getting both greens. The probability of getting both blues is x plus 3 over 2x plus 3 multiplied by x plus 2 over 2x plus 2. Now, the probability of picking two pens of the same colour is either of those, so we add them because that's the OR rule, and that is what equals 27 over 55. So the reason why this one is so complicated is because we have to correctly set up the equation first. Now that I've set up the equation though, I can almost forget about my context of probability for now, and we're just working through algebraic fractions effectively, aren't we? Solving equations. So I'm just going to go ahead and multiply both brackets. Now obviously both fractions do have the same denominators, so we can just go ahead and add the numerators together, and I'm going to collect the like terms. So now we've just got single fractions on both sides of the equation. You can also simplify this fraction on the left, because can you see that all the 6 terms are multiples of 2? So I could divide this whole fraction by 2 if I wanted to make it a little bit simpler for myself. So now that I've simplified the fraction, I'm going to go ahead and cross multiply so that I can get rid of these fractions. So multiplying by both denominators and swapping them to the other side. And now I've got just one single line. I'm going to try and collect the like terms. As you can see, we've ended up with a quadratic overall. So I will want to get all of the terms onto one side of the equation and a 0 on the other. And the way that I decide which side to move everything to is where the x squared would remain positive. So I'm going to move all of the right hand side to the left, because that would mean I would still have a positive x squared. Now I just have a quadratic that I need to solve. I'm going to factorise it as it is a non-calculated paper, but you can technically use whatever method you prefer. So my solutions are 4 and 21. Now, if you remember what x actually was originally, it was the number of green pens, which is what we're looking for, isn't it? However, I do have 2 answers. So in this case, I do need to go back to my context and think, is 4 correct or 21? I have to choose. Now, the only bit of information that we haven't currently used yet is this. They mention that there are more than 12 pens in the box. So I can test out both 4 and 21 and make sure one of them means that there would be more than 12 pens in the box in total. So we said over here the total number of pens is 2x plus 3. So if you sub in 4 to that, that would actually give us 11 pens in total. Do you see how that wouldn't be quite enough? Whereas obviously 21 would be enough because that's more than 12 in the first place, isn't it? Which is 45. So therefore, the number of green pens would have to be 21. I would have to choose between my 2 answers. Okay, so our second question is another question 22, 5 marks this time, still non-calculator. This time, however, they are actually suggesting that we use 2 different letters rather than just one. As you can see here, they've said there are only R, red counters, and G, green counters in a bag. So they're already telling you to use algebra and that we have 2 letters, which means we're most likely going to need 2 equations. A counter is taken at random from the bag. The probability that the counter is green is 3/7. And then the counter is put back in the bag. So that is one equation there, the probability for the green counters. Then we're told that 2 more red counters and 3 more green counters are put in the bag, and a counter is again taken at random from the bag. The probability that the counter is green is now 6/13. So do you see how we've actually been given 2 things here? 2 possible equations, which is what you would need if you've got 2 letters. And for example, if you had 3 letters, you would need 3 equations, and so on. So they've said find the number of red counters and the number of green counters that were originally in the bag. So that is obviously, in this case, hinting towards simultaneous equations more specifically. So we want to basically translate all of this into 2 equations using R and G. So the first one's a bit more straightforward. The probability of picking green. If you think about how we worked out the probabilities within the tree for the previous one, the probability of picking a green one is obviously going to be G out of all of the counters. Now, if there's only red and green, that means that the counters total would be R plus G. Now that is what equals 3/7. So that's our first equation. Then the second one, we're going to use this as our basis. To pick green again is no longer just G. In this case, they put the counter back in the bag, haven't they? So we're not subtracting anything. but they've actually put in 3 more green counters. So there are now G plus 3 green counters in the bag. And then out of, the total counters in the bag has also changed. So we've got 2 more red, so that would be R counters plus 2, and obviously the G counters plus another 3. So that fraction is just a little bit more complicated, and that is what equals to 6/13. So we have 2 equations. It looks a bit odd because obviously simultaneous equations, and particularly linear ones, are normally just one line. There aren't really fractions in them. But this is basically that. All we're going to need to do additionally is rearrange them first before we can start dealing with the simultaneous equations part. You can obviously use for linear simultaneous equations either elimination method or substitution. It's whichever you prefer, so there's multiple ways to do this from this point. I'm going to cross multiply both just so I can get rid of the fractions to start with and see if I can collect the like terms. So for the first one, it's a little bit more straightforward. We're going to get 7g on the left, and if I multiply r plus g by 3, that would be 3r plus 3g. Now, I'm just going to collect all of the g's together in that case. So I'm going to take away 3g, which is 4g is equal to 3r. So that's fairly straightforward. Our second equation, first of all, I think I'm going to add together the 2 and the 3. So plus g plus 2 and 3 is obviously 5. So just to make that a little bit more straightforward. And again, cross multiply to get rid of the fraction format. The left-hand side is multiplied by 13, so 13g plus 39. And the right-hand side is all multiplied by 6, so 6r plus 6g plus 30. Now, we can obviously collect 39 and 30 together. I might move 30 just to leave the 39 as positive, and I'm going to get the g's together. So take away 6g, leaves us with 7g, and take away 30 leaves us with 9, is 6r. So these are still exactly the same equations, I've just rearranged them and simplified them. Now I can start looking at solving them as simultaneous equations. I think I might use substitution looking at the r's. This is 3r, this is 6. So I would just have to double 4g to get 6r, and I could substitute it in, or you could use elimination, as we said. So that would be 8g is equal to 6r. Do you see how now I could replace 6r with 8g? So let's write that up here. 7g plus 9 is equal to 8g. Because I now have an equation with only one letter, I can just solve it. So minus the 7g leaves me with just g, 1g. So in this case, g is 9. Now, because I use g referring to obviously the original number of counters, that is just the number of green, isn't it? And the last thing is then to use the 9, sub it back into one of the original equations to find r. You can use either. I'm going to use the 4g equals 3r because that's a bit simpler. So 4 times 9 is equal to 3r. That's 36 equals 3r, so obviously then r, or red, is 12. So the simultaneous equations bit was actually kind of easy. It was just more so setting up the equations again based on how probability works, and then simplifying them from there. Okay, question 24, another 5 marks. This is now paper 3, so technically you can use a calculator. So here they've said there is a total of y counters in a box. They've given us, again, letters to use. So y is the total number of counters. There are x pink counters and 5 blue counters. The rest of the counters are green, so we've got pink, blue, and green. They've told us this ratio, so the number of pink to the total number of counters is 1 to 3. Frida takes at random 2 counters from the box. So again, this is telling me I'm probably going to need to draw a probability tree, or if you can just at least envision it in your head, that's absolutely fine. So find in terms of x an expression for the probability that Frida takes 2 counters of the same colour. Give your answer as a fraction in this format where a, b, c, d and e are integers. So can you see here how we've got 2 letters, but they haven't given us enough information for 2 equations. Hence why, in this case, we're not solving anything, we're not finding any numbers, they're just telling us to leave it in a certain format with one of those letters left. So I'm going to set up my probability tree. Now, it's a bit more complicated because there are technically 3 colours. So the first counter, again, they've told us that Frida takes at random 2 counters, so that's making me think that she's not going to put one back, she's not going to replace it, she's just going to take one and then immediately take another. So we've got pink, blue and green. Now pink, the probability of picking pink is x out of how many counters? Well, there's y counters in total, so x out of y. Now, because they said find an expression for the probability that breeder takes 2 counters of the same colour, I'm going to follow this. My second counter would have to be pink again, wouldn't it? I'm not going to draw the other options because it's just going to be massive otherwise. So pink once, and then pink again is now, because she hasn't replaced that counter that she took, is now x minus 1 over y minus 1. Then we move on to blue. Now they've actually told us how many blue there are, so that's 5 out of y. And then again, to get the same colour, it would have to be blue again. That would be 4 out of y. And finally, for green, the rest of the counters are green. So to find the numerator, or how many green there are, we can write it as y, which is the total, minus the x, which is pink, minus 5. Oh, this is also minus 1, isn't it? Over the total number of counters. And then to get green again, it would be the total number of counters minus the pink minus the blue, but technically, because we've already picked out one green one, it's minus another counter, isn't it? So that overall I'm going to make minus 6. And then over y minus 1 because we've taken out a counter previously. So that's our probability tree for the options that are actually relevant to picking 2 of the same colour. So Frida can either get 2 pink, 2 blue, or 2 green. And that would equal to this in the end. So now we need to put it together again. When we work between the branches in a tree, we multiply, don't we? So I'm going to come up here, I've got some space. So pink would be x over y multiplied by x minus 1 over y minus 1. Now, that's one option. Blue is another, green is another. Technically, you'd then add them all together, wouldn't you? So we're going to put plus blue. Blue is 5 over y multiplied by 4 over y minus 1. Plus the final option is obviously both green. Let's move this over a bit. For green, y minus x minus 5 over y times y minus x minus 6 over y minus 1. Now, this doesn't equal to anything because in this case they haven't told us a probability. We're just going to end up with an expression, so it's not an equation this time, okay? So that's different to the previous ones. Now, you could obviously expand this, add them all together. However, did you notice that our answer only has x? Now, I know that it's got a, b, c, d, and e, but obviously those would be numbers, wouldn't they? Those would be integers. So in terms of just letters, we should only have x left. The problem here is that we've got all these y's. Now, you could obviously have dealt with this at the beginning if you prefer, that's also fine. But this is where the ratio comes in. We haven't used that information yet, have we? Before I expand all of this, I'm going to change all the y's to some kind of x. So let's look at this. X to y is 1 to 3. So therefore, if I put this x here, I want the other side in terms of x as well. If it's 1 to 3, then I just have to multiply x by 3. So do you see how that's telling me that y, or the total counters in the box, is equal to 3x, 3 times the pink? So wherever it says y, we can put 3x. So you can see I've replaced all of the y's with 3x instead. Now everything is in terms of x. So I'm going to go through and multiply all of these fractions and then I will add them afterwards. And given that they obviously have all of the same denominator, I can just go ahead and add the numerators quite easily. Okay, so we now have a single fraction as they asked for. Just double check, can I simplify this fraction at all? So we're looking for any of these 5 terms. Do they have any common factors? Well, between 5, 23, 50, 9 and 3, no, they don't. So no, there's no way to simplify this fraction, and it is in the format that they want. We've got a complete quadratic at the top, and then we have part of a quadratic at the bottom. So that would be your final answer there. Okay, so we've got question 21 here. Now it is only 2 marks, but I felt like it was still kind of a tricky one to maybe figure out. So we've got when a biased coin is thrown 4 times, the probability of getting 4 heads is 16 out of 81. Work out the probability of getting 4 tails when the coin is thrown 4 times. So hopefully you'd be able to recognise these numbers here, 16 and 81. Now, well, first of all, they are square numbers, but they are also both something to the power of 4. So I like to visualise this again as a probability tree, but imagine obviously 4 throws, that means 4 branches. So the first throw being heads, then the second throw is heads again, the third throw is heads again, and the fourth throw is heads again. Whatever this probability is, for heads, let's call it x, that's the probability of throwing heads once, isn't it? Now I know it's the same every time, because this isn't the context of taking a number of counters out of a box or anything. It's just the same coin, isn't it? So the probability of getting a head each time is the same probability. So I'm going to put X as my probability for getting heads. This is just so you can visualize it. And they've told us here the probability of getting heads 4 times. So remember, with probability trees, we always multiply between the branches. So the probability of getting heads 4 times, it's not 4 times X, is it? It's not 4X. It's X times itself 4 times, which in other words is X to the power of 4. So that is the probability of heads to the power of 4 is what is equal to 16/81, which is why I said it's quite helpful to recognise the numbers they've chosen. Because yeah, I know they are square numbers, but in this context they are also something to the power of 4. So if I were to apply the 4th root, which you can obviously do on your calculator, this is a calculator question, you could also work it out yourself, that's fine, but as a fraction, that's 2/3. So remember I said what X was. X is the probability of getting heads each time. So you don't necessarily have to write all this down, it's more so just this bit here. It's X to the power of 4, so therefore do the opposite. So the probability of getting heads each time I throw this coin is 2/3, 2/3, 2/3, and so on. Therefore, the second part of this question is work out the probability of getting tails 4 times. So being that it's a biased coin, we obviously know the probability is either heads or tails has to add up to 1. So tails is therefore 1/3, isn't it? Because those two add up to 1. So then, do you see how it would be another 1/3, another 1/3, another 1? You can kind of get the gist. So what we need to do to find the probability of getting tails 4 times, again, it's not 4 times 1/3 because that would be more than 1. It's 1/3 multiplied by itself 4 times, or in other words, to the power of 4, which would be 1/81. So I'm just trying to relate this one. A lot of the questions do relate to probability trees. If it helps you to visualize it by drawing those trees down, or at least in this case drawing parts of those trees, then feel free to do that. Okay, our final question is a question 18, 4 marks. It is non-calculator again. So this time we've got spinner A and spinner B are each spun once. The probability that spinner A lands on red is 1/4. The probability that both spinner A and spinner B land on red is 1/24. So this is again telling me that I could use a probability tree because I've got 2 events. One is spinner A, one is spinner B. Work out the probability that one spinner lands on red and the other does not land on red. So again, I like to draw this out. So this first one is spinner A. We've obviously got red, and then I'm just going to say not red. The probability of getting red for spinner A is 1/4, so I can write that in immediately. The probability of not getting red is therefore 3/4, because that adds up to 1. Then spinner B, again we've got red or not red. Now this one though, we don't know the probabilities individually. So red and not red. What we do have is this second sentence here. The probability that both A and B land on red is 1/24. So let me highlight that. Red for A, red for B, I'm just going to put in X as the probability of red for B, is equal to 1/24. So you would multiply between branches. So that's 1/4 multiplied by X. Do you see how that equals the 1/24? And from here I could then just work out what X is. So you can either divide by 1/4, which I feel like is probably more complicated, or the same thing is to times by 4. So just saying that because it's non-calculator. Multiplying by 4 would be 4/24, which is then simplified to 1/6. So the probability of getting red on spinner B, we rub that out, is now 1/6. So then not red would be 5/6, wouldn't it? Same here, 1/6, 5/6. Now, obviously A and B are separate spinners, so whatever happens with A does not affect the probabilities of B, so that's why I've kept the same ones. So back to our question, work out the probability that one spinner lands on red and the other spinner does not. So if I get rid of my original highlights, let's highlight our options. So one lands on red, one does not. So it could be A red, but then B would have to be not red. Or it could be not red for A, but then B would have to be red. So do you see how we've got these 2 options here? Let's move this out the way. So let's work out probabilities. This is now just normal probability trees, isn't it? The blue option, so red A, not red B, is 1/4 multiplied by 5/6. So you'd have to obviously be happy with fractions as well. So that's 5/24. And then the green option, 3/4 multiplied by 1/6 is 3/24. And remember, when you have multiple options, we then add them. So that's 5/24 plus 3/24. Luckily, they obviously have the same denominator, so I just add the numerators. That's 8/24. Now, with probability, they don't really mind about you simplifying the fraction, so you could leave that as your answer. That does quite clearly simplify to 1/3, doesn't it? So either 8/24 or 1/3 is fine for your answer. So thanks for watching this video. It was some of the hardest Edexcel probability questions. If you haven't checked out the most common Edexcel probability questions, then definitely go back and have a look at that one as well. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.